Good morning, students. Today we will discuss about electrolytic dissociation. The process due to which an ionic compound dissociates into ions in the fused state or in aqueous solution is called electrolytic dissociation. That means the separation of the ions will be taken place in the substance itself. That itself is called as dissociation. In ionic compounds, the ions will dissociate in the fused state or in aqueous solution. If it is in solid state, it will be in the form of the solid substance itself. The dissociation will not take place. But if it is in the fused state or in aqueous solution only, it dissociates into ions, and this process is called as electrolytic dissociation. Electrolytic dissociation of a sodium chloride. Solid sodium chloride is an electrovalent compound. This electrovalent compound is also called as ionic compound. Sodium and chloride ions are not free but are held together by an electrostatic force of attraction and hence does not conduct electricity. That means if you take the solid sodium chloride, that does not conduct electrolysis. But why it does not conduct electrolysis? Because due to the electrostatic forces, that electrostatic forces will bind the sodium and chloride ion. See here the picture of sodium chloride, sodium and chlorine, and the forces of electrostatic force is holding that sodium as well as chlorine, and whenever it is dissolved in water or if it is melted, it conducts electricity. In aqueous state, the slightly negatively charged oxygen atoms of the polar water molecule exert a pull positively charged sodium ions. So, whenever it is in aqueous state, that means if you mix the sodium chloride, solid sodium chloride in water, then what happens? Here NaCl, this in the NaCl, the water, oxygen and water molecules will be there, no? So that this negative oxygen will be having the attraction power on the positive ion. Understand? Or otherwise this H plus ions will be taking this chlorine ion. So in aqueous state, slightly negatively charged oxygen atom of the polar water molecule exert a pull on the positively charged sodium ions. Similarly, pull is exerted by the slightly positively charged hydrogen atoms of the water on the negatively charged chloride ions. So, if oxygen is pulling the sodium atom, these hydrogen atoms will be pulling the chlorine atom. And thus the ions become free in solution, and these free ions conduct electricity. That's why only in the aqueous state or in the molten state only it will conduct the electricity. See here in the molten state, the high temperatures required to melt the solid and weakens the bonds between the particles and the ions are set free. That means if we heat that substance, it will melt, and due to the high temperature which we are producing, the bonds, the electrostatic force of attraction which is there between sodium and chlorine will be weakening. It will weaken the bond and the bond breakage will be taken place. So that here in this state, whenever sodium chloride is in the aqueous state or in the molten state, it will be taking place of electrolysis. Whenever it is in the solid state, solid sodium chloride does not conduct electricity. Only the aqueous or melted sodium chloride will conduct the electrolysis. Ionization. There are certain covalent molecules which are not made up of ions but forms ions when dissolved in water. These solutions conduct and electric current. For example, covalent molecules. These covalent molecules are not made up of ions but forms as ions when dissolved in only water. This process by which polar covalent compounds are converted into ions in water solution is called ionization. Example, hydrogen chloride. In gaseous state or in liquid state, hydrogen chloride is unionized and does not conduct electric current. We know that HCl is polar covalent bond. What is the meaning of polar covalent bond? There will be a bond, but the bond will be completely moved towards the electronegative element. And see here, the bond is completely moved towards the chlorine atom, so that there arises a partial positive and partial negative charges. Hydrogen got partial positive charge and chlorine got partial negative charge. Why? Because the electron cloud is nearer to the chloride ion, chlorine atom, so that it is getting the partial negative charge. And here, for this, whenever we are adding water, whenever it is HCl is dissolved in water, so that the bond breakage will be taken place. And here also water is also the